Hello, my name is David Shaw. I'm here to introduce the LVTGO-VBS, our low voltage EMC standards and robustness test unit. The system can help you to test to many automotive standards, including ISO 16750, CLISO 11979 and JLR CI 265. I'm going to show you how easy it is to build and deliver your first waveform. Later on, I'm going to talk about randomizing waveforms and the many other waveform types the unit can deliver, which are common throughout automotive testing. Let's get started. On the table here, we have a standard lab scope, the LVTGO hardware, and a laptop running LVTest, which is our low voltage test control software. As you can see, there's a CAN data connection between the LVTGO and the laptop, a main supply for the LVTGO through our separate power supply LVT-PSU, and our scope is linked to the output stage of the system. To configure our first test, we'll need to open up the LVTest software package. To do so, simply double-click the LVTest icon on the desktop. This firstly loads our real-time interface creation package Visual Connects, then the LVTest suite within that. The LVTest suite is composed of a series of forms that you can see appearing at the base of the screen now. In this demonstration, we'll deliver a typical cranking waveform to our device under test. Once the program is fully loaded, we'll need to click the Run button to enter the LVTest GUI, so let's go ahead and do that. Before making a selection, the GUI gives us a quick preview of the waveform we're about to deliver. Making a selection brings up this screen, which shows a live feed of waveform delivery. To begin with, there's nothing to see, but since we've selected our generic waveform type, testing can theoretically begin immediately. As you can see, the LVTGO is now delivering a waveform to the device under test. Since we've not specified any randomization values yet, it's just delivering the same waveform profile over and over. Still, within the space of a minute, we're now subjecting the device under test to meaningful test conditions. The LVTGO is much more powerful than this, however. Its main strength lies in the randomization of these profiles, allowing tens, hundreds or thousands of tests to take place close to known failure points. It does this by breaking waveforms down into segments of time and voltage, then randomizing these values for each cycle that's played. Let's see how this is done. We'll need to head into voltage and time settings, labelled U and T respectively. Let's head into U settings for now. Here, you can specify values for each of the points labelled on the right. In each case, we'll first select if we want the value to be fixed or randomized. If we're looking to randomize, we'll enter maximum and minimum values and the resolution we'd like the LVTGO to use for this randomization, for example in units of 0.1 volts. We can do this for as many or as few values as we like. Using our Genix technology, we can optionally configure the output to have a fast falling edge. We can also configure ground offset up to 2.5 volts. Once complete, we can head into the T settings menu and specify more values relating to the time these segments take to complete. For now, we'll leave these as they are. Now if we head back into the waveform main screen and run the waveform again, we can see that the elements of the profile we've chosen to randomize are now changing during each cycle. Now the randomized waveform is being delivered to the device under test, represented here by the scope. And since this randomization is defined by an algorithm, we can go back to any cycle of that algorithm and repeat it. If, for example, your test procedure showed cycle 250 caused the device under test to fail, this waveform can be quickly and easily replayed by selecting a start point of waveform 250. After a short period of calculation, the system will resume by playing waveform cycle 250 from the same mathematical sequence, allowing you to investigate and confirm causes of failure. So, we've now seen how to load the LVTest GUI, how to select a waveform type, how to randomize waveform parameters, how to deliver your waveform to the device under test, and how to repeat waveform cycles, windowing in on known faults. Many thanks for watching. Join us again next time when we'll be looking at the LVTGO range again in more detail.